Lesson 4.4 is parallel and perpendicular lines. Parallel lines have the same slope and different y-intercepts, so they look like this. A key part is that the fact that they never intersect because of these same slopes. Perpendicular lines have opposite reciprocal slopes, so if you multiply the two slopes together, you would end up with -1. So flip it over and change the sign. And they intersect at a right angle, so whenever you have perpendicular lines, they intersect at 90 degrees. So here's two examples. The first one has the trajectory lines of two cargo ships given by L1 passing through points 0, 0.5, and -1, and -7, -1.5, and L2 passing through points -4, and 3, 2. So we want to determine whether those two lines are parallel or if these cargo ships are going to intersect. And then number 2, we have a roof structure that's to be supported by a perpendicular bracket. The roof line L1 passes through the points -6, 2, and -1, 4. And the bracket line L2 passes through the points 3, 5, and 5, 0, and we want to determine whether the bracket line is actually perpendicular to the roof line. So go ahead and pause the video and determine whether the first example they're parallel and the second example they're perpendicular. So for the first one, I found the slope of each line. So for the first line here, I have -1 minus -1.5 over 0.5 minus -7, and you end up with a slope of 0.0667. The second one, I did 2 minus 0 over 3 minus a -4, and ended up with 2 over 7, which is 0.286. Because these two are not equal, they are not parallel to each other, and so therefore they will intersect at some point. So if you haven't already done so, go ahead and pause the video and do number 2. So I did the same thing on number 2. I found the slope of the first line to be 4 minus 2 over -1 minus a -6, so 2/5. And then the slope of the second line, 5 minus 0 over 3 minus 5, was 5 over -2. These are opposite reciprocals of each other. They're flipped over and the opposite sign, or when you multiply them together, you get -1. So therefore, yes, these two lines are perpendicular to each other. Just a little notation, these two straight lines next to each other, kind of like the two L's in parallel, means parallel. And then this upside down T looking thing, that is perpendicular. So this bottom line here says L1 is perpendicular to L2. So example number 3, a plane flies along a straight line with equation y equals 2x minus 5, and we want to determine the equation of the line which represents the trajectory of another plane flying at the same altitude that should not intersect the first line and should pass through the point 3, -1. So write the equation of this second plane. So since they're flying at the same altitude, that's the same gradient, and you do not want them to intersect, that means you want them to be parallel. So we want our slopes to be equal. So if I look at the equation of the first line, I have that my slope is 2, so my new slope is also going to be 2. And then they give us a point and a slope, so I'm going to use point slope form or point gradient form of the line. So y minus our y coordinate is equal to our slope 2 times x minus our x coordinate. And I simplified the y minus a -1 into y plus 1. If you simplified it into slope-intercept form, you'd end up with y equals 2x minus 7. So they have different y-intercepts, the same slope, so they're parallel, and that's the equation of our new line. So building off of this, a perpendicular bisector, which is something that we constructed back in geometry, is the line that passes through the midpoint of a line segment and is perpendicular to it. So if we have this line segment AB here, if we draw a line that goes through the midpoint, which I called M, and is perpendicular, this is the perpendicular bisector. It bisects, so it splits these two sections in half and is perpendicular. Another key piece with perpendicular lines is if you have a point A out in space and you have a line BC that's not, point A is not on BC, and you want to find the shortest distance from point A to this line, the shortest distance from a point to a line is always the perpendicular. So point D is on line BC, making AD perpendicular to BC. So the shortest distance between a point and a line is always the perpendicular. So given this information, we want to find the equation of the perpendicular bisector for the line segment whose endpoints are A, 1, -1, and B, 5, -3. So find the perpendicular bisector of AB. So perpendicular bisectors go through the midpoint and are perpendicular. So the first thing I did was I found the midpoint of AB. So midpoint, take the average of your x coordinates, average of your y coordinates. Point M, or our midpoint of AB, is at 3, -2. So I have my point now. So now we have to find the slope. So I know it's perpendicular to line segment AB. So first I need to define the slope of line segment AB. So finding the slope of line segment AB, I found that to be -1/2. So then if I want it perpendicular, I need to take the opposite reciprocal, so my new slope for my perpendicular bisector is going to be 2. So it goes through the point 3, -2, and my slope is 2, so using point slope form of the line, I end up with y plus 2 equals 2x minus 3. Or if you simplify it into slope-intercept form, y equals 2x minus 8. So perpendicular bisectors, they go through the midpoint, and they are perpendicular to your given line segment. So our last example, a robot vacuum cleaner is located at point A, which is at 410, and it's moving in a straight line towards point B, which is at 19.5, and the charging station is over here at point E, 6,3. So the vacuum cleaner will have to return to point E before it can get to B. So it's going to get here, it's going to die, it needs to come over here to point E. The way it's programmed is it's going to follow this line until it gets to a point where the shortest distance to E. So it's going to keep going on this line until you have your shortest distance to come over here to point E. So you're looking for the shortest distance from a point E to this line AB. So find the coordinates of D where it's actually going to turn and come towards point E. So pause the video and try that. So just a reminder, the shortest distance from a point to a line is through the perpendicular. So the first thing I did was I found the slope of the original line AB and found that it was -3. So the slope of ED, E being where our charging station is and D being on the line AB, is going to be 3. So if you haven't already finished, go ahead and pause the video and find where point D is. So the way that I did it was after finding the two slopes, I wrote the equation of the two lines. So given the slope of ED was 3 and point E goes through 6, 3, I wrote the equation of the line y minus 3 is equal to 3x minus 6, and then I simplified it down into slope-intercept form, so y equals 3x minus 15. And then for the line of AB, I took the slope of -1/3, and I took point A, and I plugged it in, got y minus 10 is equal to -1/3 x minus 4. Again, I simplified it down into slope-intercept form and got y equals -1/3 x plus 34/3. The reason I simplified these into slope-intercept form is we want to find where they intersect. So I wanted it nice and easy for substitution form. So I set both of these equal to each other to find where they intersect because that's going to be point D. And I found that the x coordinate is equal to 7.9. And then I plugged that into the first equation and got the y coordinate was 8.7. So point D is on this line here of AB, and it's the point where the robot vacuum will turn and make a right angle to go towards its charging station. So again, the shortest distance from a point that's off the line to a given line is always the perpendicular, so you can use slopes and equations to find the point where these two intersect. So this has been parallel and perpendicular lines, and also specifically looking at perpendicular bisectors and distance from a point to a line.